Today we will talk about one of the PMTS technique. This technique is predetermined motion time study method, and you know that this technique is based on the use of the databases which were developed over period of time, and these are mostly the company specific, and the companies develop their own databases for internal use, so that the time for performing any new activity can be calculated using this approach. I will talk about one of the PMTS techniques. There are four common PMTS techniques, but since this is a more advanced in nature, so we'll be talking about the one technique only. So as I talked in the previous presentation, like PMTS, predetermined motion time study method. So this method uses the fundamental motions involved in performing any manual activity. At the same time, it also considers some of the mental activities used during the performance of the job. So whatever motions and the mental activities need to be used while doing a particular job, the time values for those activities and motions are identified, which have been developed over a period of time. So although these fundamental motions and activities are specific to the method, and they are categorized and grouped in different ways, but their general approach is the same, wherein the fundamental motions and the activities needed to perform a job are identified, and the time values for those activities is used to come up with the time required to complete a job, so that the time standard can be set. And you know that this application of this method doesn't require actual performance of the job, but basically the time is synthesized using the tabular data available from the earlier records. Okay, so it doesn't require the actual performance of the job, and this gives the lot of utility and the benefits, especially in setting and designing the line, or if assembly lines. If the line is unbalanced, that also can be estimated using this method, and the suitable design of each station can be evolved, so that the line is more balanced, assembly line is more balanced. It is also used at the design stage, in design of jigs and fixtures, which will be affecting the different actions that will be needed to hold the tool, to hold the workpiece. So when the time is estimated using the PMTS method to hold or unhold the job using a particular design of the jig and fixture, so we since using this method, we are able to estimate the time a job will take to hold or unhold using a given design of jigs and fixtures. That gives us opportunity to adjust, to alter, modify the design in such a way that that it can be done in earliest possible manner, or it can be done in easiest possible way. So the design alterations and the modifications, design of jigs and fixtures is also possible. We can also estimate where what will be located, so that it will be possible to come out with such kind of the locations of the tools, workpiece, and the different parts need to be assembled or need to be used during the work in such a way that the time required to the job can be reduced, or the time can be estimated in advance without actually performing the job. So workplace design related thing also can be done. Of course, like the common one is like the standard. When the standard time is calculated, we will be in position to estimate the capacity of the plant in advance, the kind of the resources in terms of the man, machine, land, or the material that will be needed for producing or for achieving the desired output, considering the standard time. So there are many things which are doable using the PMTS method and which are beneficial, but since this method is based on the detailed analysis of work method, how a job is being done, that is analyzed in all the PMTS methods. The different steps involved in performing a job are analyzed in order to find out what are the fundamental motions involved, so that the time value for those can be estimated. Okay, time value can be identified in order to arrive at the total time required for completing the job. Okay, so basically the analysis is key, and that needs a lot of expertise and experience, and that is why it is not easy to apply. This is not a technique for learners or beginners only. So this is one aspect which is not really that good, because it is a costly affair to hire or to have the people with the desired expertise and the experience. And another thing is that it may require a lot of time also to come up and analyze the things properly. So if the jobs are very complicated, involving a lot of manual activities which are not there in any of these methods, so it may not be possible to arrive at the standard time at all using these PMTS methods, because huge range of the actions and activities may be involved in many jobs for which there is no specific time value available in the database. So it is possible that we may not have the time values for certain activities, elements, and the motions involved in performing the job. Okay, so that is the another side or the negative side of the PMTS methods. So there are, as I have told you yesterday, there are four PMTS methods which were developed long back. One is the work factor method, commonly designated as WF. Another is the motion time measurement method, commonly known as MTM method. And then there is a basic motion time method. So this is known as BMT. And the lastly, dimension motion time method, DMT. So we'll be talking in a little bit detail of the work factor method, how it is applied, using one of the examples, so that you can understand and appreciate the approach and the kind of expertise which is needed for synthesizing the time using the PMTS approach. So as I said, there are the different these are the four common PMTS approaches which are very popular and have been in use since long. But apart from this, there can be many other company specific or organization specific PMTS systems. Okay, So that is another thing, like many organizations and companies have developed their own PMTS systems, but they largely work on the similar kind of the principles of analyzing the methodology of performing a job and then assigning the time values, or using the time values available in the database to arrive at the time required for completing the job. Okay, so out of these, how to select, say, selection of suitable PMTS system, that depends on the certain factors like cost. As I said, it needs the expertise, so that is costly affair, and it needs a lot of time in implementation of these PMTS methods. So the cost associated with the expertise requirement and the time requirement, both these will be leading to the little costly affair related with the use of PMTS. So different systems will be costing in different ways, because the extent of analysis involved may be different, their approaches may be different. Then the second one is the performance level. Like the PMTS systems developed by one particular company for one set of the activities. Okay, so considering the certain performance levels, that basic time motions have been identified. The time values for certain elements and activities have been identified for a system, for system of the man and machine. Okay, and the time values for certain elements have been identified. When the same system of the time values is implemented in another system where the machinery is not that efficient and effective, people are not that efficient and effective, so the performance level may be significantly different of the different systems. So to deal with this situation, it may be required to use some adjustment factor or some kind of the multiplying factor, and this factor may be applied to the time values available in the database, so that it can be so those the time values which are multiplied by the certain adjustment or multiplying factor values, considering the higher or lower performance of a particular system, the suitable time values for those elements is identified and used to determine the time that particular method will take in a new system or in a different system. So I'll give one example, like activity A is in a system, say, for which study was performed, it takes 12 seconds. And in a same activity, when it is performed in another system, people are more efficient, so they may multiply some factor and say the time is coming out 10 seconds, and where people are slow, they may add some time values by using some another multiplying factor, giving the time of 14 seconds. So these 14 or 10 seconds can be used instead of the 12 seconds which is available in database, as per the performance possibility or performance rating of the different systems. And this is the job of the studyman or the expert who is applying the PMTS system. So this is a little subjective in nature, as far as the identification of the multiplying factor is concerned, considering the performance rating of the different system is concerned. Then another aspect related with the another factor which is considered in selection of the PMTS. So one is the cost, the second is the performance rating, and third is the nature and the type of operation. See, a PMTS system which have been developed for certain type of the operation, that should be used for similar other kind of the operations, Okay, so if there is some kind of system, say for machining, then for machining type of the operations that should be used, not for forging or for casting kind of operations. So the PMTS system being applied which has been developed for a particular type of or nature of operations, that should be used for the similar similar nature and the type of operations for establishing the time value using these PMTS systems. So that's the third one. And then one more is the consistency. Okay, consistency. So we have to see really if the job is repetitive in nature, then it is good. If the job is irregular and it's a random kind, then probably the low cost methods can be chosen. Although it is not advisable to conduct the PMTS if the job is highly non-repetitive kind. Now we'll talk of the work factors method little in detail. So work factor method, this involves basically the analysis of the job or the job method to arrive at the time value. So how we arrive at the time value, analysis of the job involves the what are the body parts being used in performing the job. So body part or body members being used in performing the job. Then the second is what is the distance to be traveled by a body member during the performance of the job. Third is the degree of control needed while performing the, like there is a free movement or very restricted or precise movement is needed, there is a definite stop or a start kind of thing. So the degree of control which is needed in the movement when the job is being performed. And the fourth one is like the kind of the resistance or the weight which is to be handled, weight or the resistance that will be imposed during the work on the movement of the body parts. So any job or method is broken into the finer fundamental motions, and those motions are analyzed considering these four parts: the body member involved, the distance being traveled, the degree of control needed, and the weight or the resistance offered while the movement is taking place. So when a job is when it's a particular element involving either leg or just foot or the finger, based on that the time is identified. The distance traveled is just 2 inches or the 12 inches. It is a free movement or a definite stop or a start or very controlled movement is needed. There is a steering, there is a change of direction, there is a continuous control of something is needed. Or likewise the weight is just like 2 kg or the 10 kg weight is to be moved. So depending upon the analysis of a particular fundamental motion and these factors, the work factors are identified, and for each factor there is a time value. So basically what we do, there is a kind of the distance like this, then work factors WF. So there are different factors, like if just body movement is involved, it is considered as one factor. If the body movement is involved with a certain distance movement, then there is a second factor. Degree of control is involved, third factor. If there so more the number of factors, more the number of greater will be the time taken. So here what we do, the distance is one, and then another factor that the weight for which the time values are identified, and between these two, say work factor 1, 2, 3, 4. Depending on the number of work factors involved, the time value will keep on changing. Say 2 inch, 4 inch, 6 inch, 8 inch, 8 inch movement, and the weight. Okay. So what we do is here the time is mentioned. The work factor, just one factor is involved. Time is say 10 seconds or TMU or any other unit. If the two work factors involved, time may be 18. 3 work factors are involved, then there is a so these are basically the work factors. How many work factors are involved in performing any fundamental motions? So for 3, say 22, and say 28. So increasing the number of factors, greater will be the time required for doing the same distance traveled. Then for these 1, 2, 3, 4 work factors case, you say the distance traveled is 4. So here it is say 14, 25, say 28, and say here 36. So this will keep on increasing, okay, like this. Similarly for weight also, up to weight for male and female, the different categories. So if up to say 2 pound, there may not be any effect if it is 7 pound or 12 pound or 16 pound, like this. So the different amount of the weights involved, they will be leading to the different work factors. So the things that are affecting is, one is distance, second is weight, and third is like say the body member. So this kind of the tables are there for each body member, say for fingers, for arms, for legs, like this. So basically in work factors method, there are different tables showing the time values, which will be giving showing the time values for distances, different distances to be traveled, with the different weights, okay, by male or female, by the different body parts. So there may be, so each table corresponds to one body part, okay, one body part which is involved in motion. So any simple activity is analyzed considering these body parts. In body part involved, distance traveled, degree of control needed, and the weight involved, okay, weight or resistance involved. So this is the method. This is the work factor method. So a work factor method is also of the, there are 3 different or 4 different types of the work factor methods, WS. So first one is called detailed work factor method. This is called DWF. This gives the most accurate, highest accuracy, and but at the same time it is most difficult and time consuming. So it will be used only when the high returns are expected with the precision in the time value which is being set. So return and the benefits, considering those things, the DWF is applied, detailed work factor, because this gives the most accurate the time values, although it is very time consuming. So this should be used only considering the economic aspect, if there is a scope of the significant returns. Then there is a simplified work factor method, SWF. It takes about half of the time as compared to the DWF. So with respect to the DWF, it takes approximately half of the time, and the reasonably good accuracy is realized. Then there is a third work factor method, is abbreviated work factor method. This is called AWF, and this is applied when the cycle time or the job cycle time is greater than 2 minutes. So this takes further lesser time as compared to the simplified work factor or detailed work factor methods, but it is quite good the accuracy as far as the time is concerned, especially when the cycle time is greater than the 2 minutes. And lastly, the very simple and easy to use method is ready work factor method. It gives the quick evaluation, measurement, and the comparison of the alternatives. Okay, comparison of the alternative options available. So we will be talking about the example related with the detailed work factor methods. Others are somewhat simpler, they take less time. So we will try to learn the things as far as the PMT is concerned using the detailed work factor approach. Okay, so now I will see say, as I have said, the body member involved in performing the job. So it can be like, say, simple arm, okay, can be fingers, can be legs, can be the trunk movement. So likewise, and then there is a kind of the fundamental motions or the elements which are involved in performing the job also have been identified. Okay, so that you can use for the analysis of the motions involved. Okay, so these are like these are called the fundamental motions or activities involved, like the transport, grasp, the release. These are like thermalics only. Preposition, assemble, use, disassemble, and so these are the some of the fundamental motions. Then the kind of the degree of control of the body movement involved is like steering, continuous steering, or the positioning. Likewise, so there are many others. And the distance and weight I have already told. Like the distance to be told is it's like 2 inch, 4 inch, 20 inch, like that. And the weight, how much weight is to be handled during the manual activities. Okay, so any job is analyzed considering these aspects. Now I will quickly go through the PPT, which will be showing the details as well as the examples. So here, if you see, these are the different types of the PMTS systems. I have already talked about this. And the selection of the particular PMTS method is based on the like installation cost and and its application in form of like the expertise cost or cost of expert, and the time involved in. As far as the kind of performance level is concerned, the different industries may have the different performance. So that so if it is to be implemented in a particular system, we need to use the suitable multiplying or adjustment factors to the time values which are given in the PMTS table. And the consistency of the standard, like if we have to see like if this one will be fitting in our case or not, that can be done on the trial basis. So instead of implementing the PMTS related the database or related with the standard time, let us try the standard time obtained from the PMTS for few operations, for few activities, so that their feasibility and their correctness can be checked. So on the trial basis it can be implemented in the beginning to see if it is okay or not for a particular company. Then nature of the operations, as I said, the most suited for the similar type of the operations and the natures, and it should not be implemented for entirely different type of the operations. So the work factor, as I have already said, like it provides the time values in tabular form for the different manual operations and the manual mental processes. And in this method, the method of performing the job is analyzed, and the activities are arranged in such a way that the time values for manually controlled activities can be identified or can be obtained. So the method of the job is analyzed, and it is broken in such a way that the time for those fundamental motions can be obtained from the available tabular values. These are very extensively used because of consistency and easy to use. Okay. I have already said about this: detailed work factor, simplified work factor, abbreviated work factor, and a ready work factor. How does it work? As I have explained, to determine the time for a given job, 4 variables are considered for the analysis. The body member involved in performing the job, like the fingers, arm, forearm, trunk, foot, leg, eyes, or head. Distances through which the distance that need to be traveled by the body part during the job, performance of the job, the kind of the weight resistance in weight or the resistance that will be there in making the motions, and the manual control that is needed, and the time unit which is used in these methods is like TMU. Actually, this is one time unit is corresponds to actually 0.0001 minutes. So this is the kind of unit which is used. The tabular values you will see in the work factor method and even time measurement method, time measurement. So in those methods, the TU, 1 TU is equal to this much of the time. So this is just for your information. Like the actual obviously we have to see what are the body parts involved in performing a particular movement. That has to be identified first. These body parts can be there in form of finger, hand, forearm, trunk, foot, leg, head, and all these. And with respect to these, the point of measurement with respect to what the distances to be traveled are measured. So actual distance traveled during the performing a job is say checked, say 1 to 40-inch distance to be traveled in, and the distance measurement of the body part is made with respect to the following points. So so say fingers are moving or the hand is moving, so based on that, the finger movement, fingertip is the point of the measurement. If the arm is moving, knuckle is the point of the. So based on the location of these points, with respect to these points, the reference points, the measurement of the distance traveled is measured, considering the movement of these body parts. Okay. For example, the distance traveled by the head is measured with respect to the change in position of the nose. Similarly, the distance traveled by the leg is measured with respect to the movement of the ankle tip. Okay. This similarly for foot, the movement, the toe tip is okay. The resistance to the motion affects the time. Of course, when the heavy resistance is more, it will be taking longer time, so obviously the more time has to be given. So this is directly related with the weight which is to be handled. I will be showing the table subsequently. The manual control that is needed in performing the job, like say definite stop, showed by the D, steering S, the precautions, and the change of direction. So the different symbols, different kind of control which is needed during the performance of the job. So motion needing the close control or exact motions, these increase the degree of difficulty and the time requirement. Okay. So as I have said, The method which for which the time is to be identified, time is to be determined, uh, it is analyzed, that method is analyzed. So in a given work motion, the standard elements of the motions are described, those are identified, and the motion within the standard elements are identified if they are being performed by which body member. So these motions are being performed by which body member, by what distance, what are the different work factors involved, what is the resistance for the movement. So these are the different activity elements. I have already told you: transport, release, grasp, preposition, assemble, and use. So the point here is these elements are being performed, okay, by the different body members, distance traveled, and leading to the different involvement of the different factors and the degree of the resistance or the weight which is to be handled. Okay, so these tables, there are of about 6-7 tables, which will give you the more clear idea of what I am talking. So that these tables are the work factor tables. These tables gives you the time for performing the different movements by the different body parts through the different distances when the different weights are handled. Okay, say for example, the first is the arm movement. So the motions being performed by arm, okay, measured at knuckle, I have already said. When the arm is moved through the 1 inch, 2 inch, 12 inch, like this, what is the distance traveled? So based on that, you will see for all work factor, one work factor, this is how the time is increasing with the distance traveled. This is the basic motion time is studied. This is not used the time which will be used for calculating the time required to complete a job is about the work factor based time values. Okay, so whether there is just one work factor or more work factors. Work factor is about the kind of resistance that will be there in. Okay, so and what are other restrictions associated with that motion being performed by a particular body part. Okay, so say this is about the distances traveled, this one by the arm. Then who is performing the job, male or female? Based on that, there is a difference in the the time values. The weight being taken by male up to 7 pound work factor is 1. For female, weight up to 3.5 work factor is 1. When the weight to be handled by arm is up to 13, the weight factor is 2. When the weight is to be handled by woman is or female is 6.5, work factor 2. So likewise, the weight up to 20 pounds by male, weight work factor 3, and greater than the 20 kg and more, 20 lbs, it is 4 work factor. So distance to be traveled by arm by a particular work factor as per the weight. Okay, we will get the different time values. Say 65, if the weight to be handled 7 pound and distance to be traveled is 12 inch, the time we taken will be 65 TMU. Okay, this one time unit, so time unit 65 time units. Okay, if the arm has to travel the 12-inch distance with the weight of 13 pounds, then the time will be 85. If it is 20 pound, time will be 102 time units, and likewise. So as per the distance, if it is distance to be traveled by the arm is 40 inches, then for one work factor, that is corresponding to the male handling the 7 pound weight, time required will be 102, 109. If it is 13 pond, then it will be like say 135 time units, 159 time units if weight to be handled by the arm of by the male of distance 40 inches, then the time value is 159, and more than this is 179. So the time units, the time required for performing a particular job, like say, or particular motion, the time required to perform the motion by arm through different distances while they are handling the different weights, those can be obtained from these tables. Okay, so these tables are simply giving us the value of the time that the body part will take to cover the different distances with the different weights. Okay, similarly the second table is this: the movement of the leg measured at the ankle, distances to be traveled is say 1 to 40 inches for male, female. If the distance to be traveled is up to 42, this is weight, the male traveling with the weight up to 42 pounds, okay, it will be classified under the one factor, and if the female carrying the weight of 21 pound, it will be classified under the work factor 1, and if the weight carried by the male is more than the 42, then it will be falling under the work factor 2. Okay, so if like say 40 pound weight is being taken, and this is say 35 is the inch distance to be traveled by the leg, 35 inch is the distance to be traveled by the leg, and the 42 pound of the weight is being taken by the man, it is 118 time unit. And if it is greater than that, say 50 pound is to be handled during the performance of a job wherein distance traveled is 35 inches, the time taken will be 147 time units. Okay, so this is how the time taken for performing the movement by legs through the different distances while carrying the different weights by male and female can be identified. Okay, similarly the time values for performing the different fundamental motions by trunk for the different distances and different weights, giving the different work factors based on the weight, can be identified. So combination of the distance traveled and the weight is giving the different work factors. Okay, basically the weight is giving, the resistance is giving the different work factors. So work factors are also added when we find that there are additional factors that will be affecting the time, like the degree of control which is needed in performing those activities, like you have seen here. The work, considering the work factors like involving the degree of difficulty, if there is any other degree of difficulties involved. Similarly, finger movements, distance traveled up to 4 inch, then the weight involved, say 2.5 or 4 pounds for female, 1.25 and the 2 pounds or so. That will be affecting the work factor, and accordingly as per the distance to be traveled you will see the different time values. Similarly for foot and for forearm swiveling movement, the time values from the work factors can be obtained. These are about the movement of the different body parts through the different distances while carrying the different weights. So now we will see one typical example related with this work factor method. Say, like, find the time required for picking up a shaft of 2-inch diameter. Okay, picking up a shaft of 2-inch diameter having the weight of 7 pound, and after picking this has to be moved through the 12-inch distances, then placing the shaft its one end inside the bush bearing by a male worker. So the time for this activity is to be identified, like the hand is to be moved by 12-inch distance to reach and then to grasp and then carry the shaft and again move it by the 12 inches, then place it inside the bush bearing for fitting purpose. So there are like activities being performed like reach, then grasp, and then assemble. So we'll talk about the first, the reach. Reach to grasp the shaft is analyzed as arm is moved by the 12 inches to get the weight of 7 pound, okay, and the D is about the analysis of the job is this element is being done like this. D is the definite stop. So arm has to move and then it has to reach up to the reach at the shaft and then stop so that it can be grasped. So it is being analyzed as arm movement by 12 for a weight of 7 pound shaft and with a definite stop D. A means arm motion of 12 inches. D shows the weight of 7 pound. 7 pound, which is up or less than the 13 pound, so it will be falling in the work factor category 1. So you have seen if the weight is up to 7, so it will be falling in category 1. Okay, so what this is work factor 1, and the distance traveled is 12. Okay, but at the same time the arm has to stop at a definite point. So D definite point, that is the shaft. So the D indicates the definite stop of the arm at the shaft. So this will add one more. So this is the motion control involved, or the degree of difficulty in performing the job is a definite stop is involved. So this will add to one work factor. So with respect to the distance, with respect to the weight, for this arm the work factor is 1, but when the motion controlled motion is involved, that is the definite stop at the shaft, then it will be leading to the one work factor. Okay, so one work factor, when it is added one work factor plus 1, so it becomes 2. In that case, that the time for the same activity with the definite stop, if there was no definite stop, time would have been 65. But if there is a definite stop, so from the table for arm A, 12-inch distance traveled, 2 work factors, the time is 85. So when one work factor is added, the time is 85. Okay, so all the weight to be handled is 7 pound, but since there is an addition of the degree of difficulty in form of the like restriction to the movement, that is the definite stop, so there will be addition of one work factor. Okay, then the second one is the grasp the shaft, the another activity after arm reaches. Grasp the shaft for this motion and analyze, this is being analyzed as F. Okay, these are the fingers. So fingers movement of the 2 inches, because the shaft diameter is 2 inches. So the 2 fingers motion of the 2 inches for a weight of a shaft of 7 pound. So this will be obtained from the finger and hand finger movement basically for 2 inches. Okay, this will be there with the, so from the table the time units measured is like say the weight, this is male, so greater than 7 pound. So this is pound, which is to be the weight which is to be handled by the fingers, like say, uh, so 2.5 pound, 4 pound, and greater than 4 pound is 7. Okay, for 7 pound, so the time uh, for grasping the 2 inch the shaft of 7 pound shaft having the weight of 7 pound, 2 and then 7 pounds. So this combination will be giving us the 38 time units, that is this. Okay, now we are at the last section only. So now once the shaft has been grasped by the hand, move the shaft by a distance of 12 inches. Okay, then place it into the bearing. This has to be analyzed as A is the 12-inch arm travel by 12 inches like the earlier one. Now the weight to be moved is like say the 7 pounds, and now S is like the steering the shaft to the end of the, so it is like controlled movement of the shaft is needed to get its one end into the bearing. So it is called like steering of the shaft. So this is one additional work factor, and D is the definite stop, because the shaft will come to the definite stop over the bearing. So what we'll see here, like arm is moved, okay, by 12, the weight is 7 pound. Now the S is the steering, that is 1 degree of difficulty steering, so 1 work factor. Okay, and the definite stop is the another work factor which is involved. Okay, this is the another work factor. So what we have, the same arm distance traveled is 12 inch involving the 3 work factors. So 7 weight is this is 1 work factor. Okay, now we had 1 work factor due to the steering and another work factor due to the definite stop. Okay, so the time the time for movement of arm by 12-inch distance with the third work factor is 102. So referring this table, the time units for distance of 12-inch and 3 work factors is 102. Now we have got the time for all these 3 different fundamental actions. These were in form of like say the reach, grasp, and then move and assemble. Okay, so here the time for the first one, reach, was 85, for grasp 38, and for the last one 102. So the total time for these these activity is 225. So this is the time unit, basically TU. So this time unit is converted into the minutes by multiplying 0.001 into 225. This will be giving us like 0.02 minutes in this. That's the time that which will be taken in performing the job. So arm reaches to the shaft is grasped, and then it is moved towards the bearing, then it is positioned, and then the shaft comes to the definite stop at the end, so that this kind of the assembly is completed, and for that time required is this much, 0.0225 minutes. So this is how the detailed work factor analysis is involved or is performed to come out with the time that will be taken in performing some kind of the manual jobs. Okay, so that's all as far as the work factor method is concerned. About the limitations of this method, I will be talking in the next lecture, and also I will talk about the standard data method. That's another data based method which is completely simpler as compared to this. So that's why we say that the PMTS method is primarily for the experts, but the standard data method can be applied by the common people, or even new learners also, that they can apply if the data is available to them. Okay, so about that we'll talk in the